main objectives of countrywide assessment and natural resources monitoring are to provide quality information for national policy processes and strategic planning. The methodologies developed by FAO are the result of a major effort and collaboration across FAO's technical departments and with international and national experts. These methodologies are continuously evolving while being adapted and applied in individual countries to meet new information requirements. This film introduces the FOA Manual for Integrated Field Data Collection, providing guidelines and descriptions of methodologies for field data collection to inventory and monitor forests and tree resources and other land uses. The guidelines are aimed at field data collectors as well as national forest inventory planners, trainers and field inventory supervisors. The methods presented in this field manual should be tailored and adapted to each country, taking into account national contexts, social and ecological environments and information requirements. These methodologies have been applied since 2000 in more than 15 countries in Latin America, Africa and Asia. The sampling design adopted for the field inventory is systematic. The number of sampling units is determined by the level of statistical reliability required of the data and the financial and human resources available for assessment, with a view to enable periodic monitoring. The sample may be pre-stratified in situations where stable strata such as ecological zones are deemed to improve the design. Data are collected in the field through observation, measurement and interviews within the limits of the tracts, plots, subplots, land use sections and household survey areas. A tract is an area of 1 square kilometre. The southwest corner of the tract corresponds to the coordinates selected in the systematic sampling frame. Each tract contains 4 field plots. The plots are rectangular areas 20 metres wide and 250 metres long. Each plot has 3 sets of subplots containing rectangular, circular and litter plots, as well as transect lines for fallen deadwood. Each plot is mapped into land use sections and intersecting roads and waterways are drawn. The land use classification system is based on a dichotomous approach and includes different levels. The first level is composed of the Global Land Use Classification System developed by FAO to ensure harmonization between countries for regional or global assessments. The global classes include forest, other wooded land, other land and inland water. The other levels are country-specific and include additional classes defined to meet specific national and subnational information needs. The organisation structure of national inventories varies from country to country, but the Forestry Authority is usually designated as main focal institution, while cooperating with other related institutions and stakeholders. A National Steering Committee overlooks the process and maintains communication with all stakeholders. A technical unit is created to coordinate, execute, supervise and monitor all activities, such as adapting the field manual and preparing reference documentation. Well-trained field teams, together with a quality control team, are very important for the quality of the collected data. Data are collected by field teams, usually consisting of 4 members, including permanent team members, but also locally recruited people who know the area well. The field teams are trained by experts from the technical unit. Together they also prepare field maps, field forms and contact local communities. During the first days of fieldwork, each team is accompanied by an expert from the technical unit.
This can be used. And it smells nice. This can be used.
It's important to present and explain the national assessment to the local population to ensure their understanding and cooperation. The time needed for data collection in each sample site depends on accessibility and vegetation type and could vary from less than a day to more than a week. The field team orient to the pre-established coordinates of the starting point of each plot using GPS receivers, well-prepared field maps and local guides. Photographs are taken for relevant sites. The position of the plot starting point needs to be precisely located by GPS receiver and marked with a permanent marker, both for future monitoring and for quality control. If there's an obstacle to establishing the marker at the starting point, such as a river, house, cropland, etc., the permanent marker should be placed as close as possible to the starting point of the plot. Marker location and reference point data must be recorded together with a plot starting point description in order to enable relocation in the future. Data collection starts at the plot starting point and continues in a predefined direction along the plot central axis with the help of a compass and a long measuring tape. To obtain accurate measurements of horizontal distances, it's necessary to correct distances for slope using the slope correction table. Measurements cover 10 meters both left and right of the plot central axis. Flagging may also be placed at the corners and limits of the plot as the team advances, in order to easily identify which trees and shrubs are within the plot. The data collection process has to be well documented with photographs. Pictures of environmental problems such as soil erosion and polluted water, as well as site-specific features such as flowers, should be taken during fieldwork. GPS coordinates are also taken at the middle and end of every plot. The different land uses in the plot are mapped into land use sections of a predefined length and width as the team proceeds along the plot. The characteristics of each land use section are registered together with observations of environmental problems, animal traces and water quality.
8.0?
Yeah, thank you.
All living and dead trees, both standing and fallen, with a diameter at breast height greater than 20 centimeters in forest or greater than 10 centimeters for trees outside forest, are inventoried, as are stumps. Tree diameter is measured over bark at breast height, meaning 1.3 meters above ground. There are many deviations from the norm where trees require special measuring. These are described in the manual. Collected data include, besides the species identification, height, diameter, health and tree quality, also their position in the plot according to their distance along the plot axis and which side they are on. Some trees are at the border of a plot. If the centre of the stem base is inside the plot, it is included. If it is outside, it is excluded.
Tree diameter 35.
In forest, trees with a breast height diameter of between 10 and 20 centimetres, together with shrubs, are only inventoried in the rectangular subplots. Small trees and tree regeneration lower than 1.3 metres and with a breast height diameter smaller than 10 centimetres are only counted by species in the circular subplots. Indicator plant species and non-wood forest products, for example medicinal plants and other special indicators, are inventoried also at this level. Data on litter, which includes all non-living biomass less than 10 centimetres in diameter, are collected on dedicated litter subplots. Photos, soil and topographic data such as slope, slope orientation and relief are collected at 3 measurement points. Soil data are collected from observations carried out in the field, sometimes associated with the collection of soil samples, which implies subsequent laboratory analysis. Fallen deadwood and branches are measured along defined transect lines located at the end of each rectangular subplot.
Three and a half.
Data on goods and services provided by forest, trees and other land uses are collected through observation and interviews with local guides and other local users. External key informants include officers from local government, NGOs, extension workers and local administration representatives. Internal key informants are usually community representatives, school teachers, traditional leaders, community-based organizations and landowners.
Bueno, ¿pueden indicarnos cuál es o qué grande es su finca, cuál es el uso actual del terreno?
La finca es de 3 manzanas y tenemos una media manzana que la dedicamos a pastos para las ovejas. También tenemos cultivos de naranjas y tenemos otros cultivos de granos básicos.
Okay, granos básicos, ¿cuáles son?
Tenemos maíz y frijoles.
Okay. Aparte del maíz, frijoles.
Para un buen año tenemos unos 10 quintales de naranjas y un quintal de nueces, por ejemplo.
All field forms must be checked by an expert from the technical unit. The forms are scanned and, together with the digital photos, saved on the server and backed up. Data are processed and analysed, and before the new statistics become official, they need to go through a national validation process. Now the final document with the results can be prepared. A comprehensive report with all the results and a booklet version with major findings for a wider spectrum of users. The findings are disseminated through various media so as to reach all relevant institutions throughout the country. Accurate and reliable information from forest inventories is immensely valuable for political decision-making and national planning for the sustainable development of rural areas, food security and poverty reduction. Sustainable management and use of natural resources is crucial for maintaining local cultures and improving the livelihoods of rural people. Reliable information on our natural resources thus plays a vital role for the well-being of humankind, for both present and future generations.